Today's session is about Steppingstone method of transportation problem. Transportation problems are solved in two steps. First step is finding initial basic feasible solution, and second step is to test that solution for optimality. Two methods are widely used for testing the solutions are modified distribution method, MODI, and Steppingstone method. Today we are discussing Steppingstone method. Approach. Step 1. Check for balance of supply and demand. Step 2. Find the initial basic feasible solution using northwest corner method or least cost method or Vogel's approximation method. Step 3. Steppingstone method. Identify an unallocated cell in the transportation table. Draw a closed path, clockwise or anticlockwise. Only right-angle turn is allowed at allocated cells and return to same unallocated cell. Assign plus and minus signs alternately at each turn. Calculate the improvement in cost that could be achieved by adding 1 unit of product from a supply cell to a demand cell in the loop. Repeat for all the loops. Assign a new plus sign to the cell that was originally a supply or demand cell on the loop with the lowest improvement in cost that is most negative. Allocate the values in the cells that are forming a closed path by adding or subtraction the value of x. Step 5. Calculate the transportation cost. Let's understand it clearly with an example. Example. Find the optimal solution of the given transportation problem using Steppingstone method. Solution. Step 1. Check for balance of supply and demand. Adding supply, total supply is equal to 225. Adding demand, total demand is equal to 225. Supply is equal to demand, here it is balanced. Use any one method to find the initial feasible solution, northwest corner method, least cost method or Vogel's approximation method. Here, we are using least cost method. First identify the cell with minimum value. 1 is the minimum value and there are two ones. We can choose any one. We are choosing this cell with 1. Here supply is 75 and demand is 80. 75 is less. Hence allocate 75. Now here 75 minus 75 is 0 and 80 minus 75 is 5. As supply is 0, delete row. Next this cell with 1. Here supply is 90 and demand is 35. 35 is less. Hence allocate 35. Now here 90 minus 35 is 55 and 35 minus 35 is 0. As demand is 0, delete column. Next minimum value is 3, supply is 55 and demand is 5, 5 is less, hence allocate 5, now here 55 minus 5 is 50 and 5 minus 0 is 0, as demand is 0, delete column. Next minimum value is 4, here supply is 60 and demand is 65, 60 is less, hence allocate 60. Now here 60 minus 60 is 0 and 65 minus 60 is 5. As supply is 0, delete row. Next minimum value is 6. Here supply is 50 and demand is 45. 45 is less. Hence allocate 45. Now here 50 minus 45 is 5 and 45 minus 45 is 0. As demand is 0, delete column. Only this cell is left. Here supply is 5 and demand is also 5, hence allocate 5. Now here 5 minus 5 is 0, supply and demand both are 0. Here, number of allocation is equal to m plus n minus 1 is equal to 6. All allocations are independent, they don't form closed path. So, solution is non-degenerate. Initial transportation cost is equal to 4 times 60 plus 1 times 75 plus 6x 45 plus 3 times 5 plus 1 times 35 plus 9 times 5 equals 680 rupees. To check whether the solution is optimal or not, we have to do optimality check. Step 3. Find the optimal solution using Steppingstone method. First, we need to identify an unallocated cell in the transportation table. All these are unallocated cells. Here we see 6 unallocated cells. We shall start with this unallocated cell O1D1. Draw a closed path, clockwise or anticlockwise. Only right angle turn is allowed at allocated cells and return to same unallocated cell. So here this is the path. It turns here, then here and finally reaches the starting cell. Assign plus and minus signs alternately at each turn. Calculate the improvement in cost that could be achieved by adding 1 unit of product, that is x is equal to 1, from a supply cell to a demand cell in the loop. Improvement in the cost O1D1 is equal to 5 minus 4 plus 9 minus 6 is equal to 4. For next unallocated cell O1D2, we shall start from this cell O1D2. Closed loop is drawn like this as. Assign plus and minus signs alternately at each turn. Calculate the improvement in cost that could be achieved by adding 1 unit of product, that is x is equal to 1, from a supply cell to a demand cell in the loop. O1D2 is equal to 7 minus 4 plus 9 minus 3 is equal to 9. Next unallocated cell O1D3, we shall start from this cell O1D3. Closed loop is drawn like this. Assign plus and minus signs alternately at each turn. Calculate the improvement in cost. O1D3 is equal to 2 minus 4 plus 9 minus 1 is equal to 6. Next unallocated cell O2D1, we shall start from this cell O2D1. Closed loop is drawn like this. Assign plus and minus signs alternately at each turn. Calculate the improvement in cost. O2D1 is equal to 3 minus 1 plus 3 minus 6 is equal to minus 1. This value is negative. Next unallocated cell O2D3, we shall start from this cell O2D3. Closed loop is drawn like this. Assign plus and minus signs alternately at each turn. Calculate the improvement in cost. O2D3 is equal to 8 minus 1 plus 3 minus 1 is equal to 9. Next unallocated cell O2D4, we shall start from this cell O2D4. Closed loop is drawn like this. Assign plus and minus signs alternately at each turn. Calculate the improvement in cost. O2D4 to 9 plus 3, 1 is equal to minus 5. This value is negative. Among all the values obtained, minus 5 is the most negative, so we will choose this loop. Assign a new values to the cell that was originally a supply or demand cell on the loop with the lowest improvement in cost, most negative. Between these two, 8 and 5, 5 is minimum, hence is assigned. Here assigned value is 5. Put x is equal to 5. Allocate the values in the cells that are forming a closed path by adding or subtraction the value of x. We start from the cell 0 to D4, add 5. Here we see no allocation, so 0. Now plus 5 becomes 5. Here 5 minus 5 becomes 0. So with no allocation, here 5 plus 5 is 10. Here 75 minus 5 becomes 70. These are modified tables with modified allocations. Calculate transportation cost is equal to 4 times 60 plus 1 times 70 plus 2 times 5 plus 6 times 45 plus 3 times 10 plus 1 times 35 is equal to 655 rupees. Here we see the cost has been reduced. Least cost method gave us 680. Here we get 655 rupees.